So that's the Enigma, and what you need to know is kind of the basic concepts. You don't need to know this whole Poland and England and historical things. It's just, I think it's interesting because it brings it to life. So you need to know that the Enigma machine did substitution. What the key was the actual rotors and how they moved. Now there's another way of doing encryption that is not using sophisticated algorithms like we use today. One example is the running key cipher. And so let's say that I want to get a secret message to you. And the algorithm itself is we have a set of books. And what I send to you, you and I have the exact same set of books. What I send to you is just a bunch of numbers. But those numbers mean something to you. That's the key. The first number could be go to the fourth book. You go to the fourth book. The next number is 4, so you go to the fourth page. Next number is 16, so you go to the 16th line. The next number is 5, and that's the word. You write that down. And you do that for each set of numbers I sent over to you, and that's the actual, until you get the full message. Now it seems like that's just kind of goofy, and who really uses that? Well, it's thought that that's actually used by criminals and terror cells, and this is something that like FBI and Secret Service are looking for, because people are communicating and they're using specific things. It may not be a set of books. Maybe it's a USA Today, the newspaper. And you and I know that we're going to use USA Today. I send you these numbers. It'll tell you which page to go to, which line to go to, what word to go to, and we're communicating that way. So anybody who grabs our message, it's just numbers, and they won't know what it means unless they figure out what our, the algorithm or the USA, that's what we're using. So that's the running key cipher. Now, concealment cipher just means that there's a message within a message. So I could write you a message, and it's long and fluffy, and it says, how are you doing, and how's grandma, and everything's okay here, all this stuff that doesn't seem important at all. But you and I have the same key. This is symmetric encryption. You and I have the same key. You know to pull out every third word of my message. And when you pull out every third word, it has a totally different message, like we're going to bomb Libya or something. So that's a concealment cipher, a message within a message. It's not actually encrypted, it's just hidden.